What if the secret to defying aging was already alive in the ocean, the forest, or even underground? Scientists are now studying these biological marvels to unlock clues that could one day help humans slow aging and live longer, healthier lives.
Horseshoe crabs, often called living fossils, have remained virtually unchanged for over 450 million years, showcasing their remarkable adaptability. They are not true crabs, but marine arthropods closely related to spiders and scorpions, with a hard horseshoe-shaped exoskeleton, a long telson tail, and 5 pairs of legs. 4 species exist today: the Atlantic horseshoe crab along North America's eastern coast and 3 Asian species. Their survival through multiple mass extinctions stems from a simple diet of small crustaceans, worms, algae, and detritus, which allows them to endure food scarcity. Their stable ecological niche, with few predators and a reproductive strategy of laying thousands of eggs during spawning season, has enabled them to thrive in environments from sandy beaches to estuaries. Their efficient physiology, including gills for oxygen extraction and a telson for righting themselves, has required little evolutionary change, contributing to their slow aging and longevity. Their bright blue blood, colored by copper-based hemocyanin, contains amoebocytes that clot around bacteria, forming a barrier against toxins. This unique immune system has made their blood critical for testing vaccines and medical devices, as it detects bacterial contamination with high sensitivity. Horseshoe crabs grow slowly, taking 10 to 12 years to reach sexual maturity, and can live for decades, with their robust immune properties preventing disease and aging-related decay. This slow aging process, combined with genetic adaptations that enhance their ability to combat microbes, allows them to maintain vitality over their long lifespans, making them resilient to biological decline. Despite their ancient resilience, horseshoe crabs face significant modern threats that outweigh the effects of aging. Overharvesting for biomedical use and fishing bait has led to population declines, particularly for the vulnerable Atlantic horseshoe crab and the endangered trispine horseshoe crab. Habitat loss from coastal development, shoreline hardening, and sea level rise due to climate change has reduced critical spawning beaches. Pollution, such as herbicide runoff, contaminates estuaries and harms egg development. The harvesting process, which involves extracting up to 30% of their blood, can cause significant mortality and reduce breeding capacity in surviving females. These pressures also impact ecosystems, as horseshoe crab eggs are a vital food source for migratory shorebirds, whose populations are declining. Conservation efforts offer hope for horseshoe crab survival. Synthetic alternatives to their blood are being developed to reduce harvesting needs, though adoption is slow in some regions. Improved harvesting practices and programs to rescue eggs from crabs used as bait are helping stabilize populations in certain areas. Protecting spawning habitats and reducing coastal pollution are critical to ensuring juvenile crabs reach breeding age, which can take up to 20 years. Continued efforts to balance their biomedical value with population preservation are essential to ensure these ancient creatures continue to thrive.
Thanks so much for watching. If you thought creatures that defy aging were wild, just wait until you see what nature's real-life superheroes can do, from regeneration to invisibility. The next video dives into animal superpowers you won't believe exist. Hit that like button, subscribe if you haven't, and we'll see you there.